Hi everyone, my name's Sarah, and in this video I'll be walking through my constant velocity lab. The goal of this project is to analyze the motion of an expo marker moving at a steady speed and compare its real-world motion to a computational model. This is just an outline of some of the things I'll be talking about for this video. In this lab, the object I analyzed was an expo marker sliding across a table. I collected two different types of position data. Measured position. This came from the tracker where I measured the marker's location frame by frame. The predicted position came from a GlowScript model that calculates where the marker should be if it moves at a constant velocity. The purpose of the lab is to compare these two sets of data and see how well the computational model matches the real motion. Newton's second law can be described as net external force equaling the change in momentum of a system divided by the time over which it changes. This experiment connects directly to Newton's second law. Since the expo marker moves at a constant velocity, this means that the net force acting on it is essentially zero. With no net force, the acceleration should be close to zero and the velocity should remain constant. This is exactly what we expect to see in both the tracker data and the computational model. Basically, I recorded a video of the expo marker, I built a computational model in GlowScript through coding, I created a spreadsheet of all of the data through the tracker, and I compared the two models using graphs. And this is the video of the expo marker. From the tracker, I found the initial position to be 0 and the initial velocity to be around 0.9. From there, I created this code in GlowScript to find the predicted position of the expo marker. After getting both sets of data, I created this graph, and as we can see, the x position versus time graph formed a straight line which indicates constant horizontal velocity. Even though the graphs match well, there were still a few sources of error. Outside forces like slight friction changes or tiny bumps in the surface could have caused discontinuity. Rounding errors. GlowScript uses small time steps and rounding can accumulate over time. And tracker limitations. Small tracking mistakes, camera angle issues, or slight axis misalignments could affect the data. So further questions, what if the positive and negative x-axes were swapped? Basically, the resulting velocity would be negative, but all the actual physics would behave the same. Thank you for listening to my lab report on constant velocity.